we'll so if you have a chance, go to chapter 30, please. Chapter 30 talk about swimming pools, spas, hot tubs, and hydro massage bathtubs. The common denominator between all these guys is the continuous presence of water in these areas, right? That's common between all of them. They all have water at all times. Spa, hot tub, hydromassage bathtub, swimming pool, they have water, and not just have water, because lakes have water too. They have water in direct contact, or people in direct contact with water. So when you have people in direct contact with water, what did they tell you guys? The shock hazard exponentially increases as you put electricity in close proximity to water, right? And you put the people in between. So that's why the NEC could take them and put them in a special article 680, to talk about the swimming pool. So why do we care about these? Why are they so important? Because there is water, there's people in the water, and there's electricity in the proximity of this water. Everybody can see, you can see the gravity of that one? Because when you have water, you have electricity, you have people in between, it is the fatal shock. When you have a shock, it's the fatal shock. Okay, so keep this in mind. So what we're going to be talking about, guys, as we move through this chapter, I really have, the most important thing about it is, I have a layout of a swimming pool with all the regulation in it. You're going to see it's really nice. Recognize important proper swimming pool wiring. Why do we care about allowing the swimming pool wiring? The human being safety. You have people in direct contact with water, with electricity in the close proximity. Fatal shock. So we need to make sure that our wiring system is safe, number one, and we have safe devices to protect the people from being electrocuted. Discuss the hazard of electrical shock. So you have electrical shock is a major hazard when it comes to water. So that's the discussion of electrical shock in a swimming pool. NEC has requirement, guys, for wiring and designing a swimming pool, as well as a hydromassage bathtub and hot tub and spas, all of them. So we're going to talk, for example, GFCIs have to be you have to have GFCIs. You can't have receptacles closer than 6 feet away from the inside of these equipments, common denominators. So these are the information I'm going to be going over. Shock. The most important thing, guys, is so-called lethal shock. Every time you have Chad in close proximity with water and connected to electricity, it's not just a shock, because you can survive shocks, guys. You have lethal shocks. A lethal shock is something that lethal, it can kill you. So you can be shocked when you're in water, when you're swimming in water, my friends. Here's Chad swimming in water. His eyes are going up here. When you're swimming in water, there are two types of shocks that you're involved in, that could be involved in. Direct shock. Direct shock is you're swimming in and you're grabbing an energized object. That's direct shock. And the other one is called voltage gradients. Probably you guys are not familiar with that. Voltage gradients. Everybody knows what a direct shock is, right? You grab an energized object while grounded. And you grab on the other side on anything that's well grounded, like an object that's wet and barefoot. And how many of you guys swim with their shoes on? Do you swim with your shoes on? Nobody swims with their shoes on for the most part, right? So that's why the perfect shock is. The perfect shock is here you are, grabbing on something energized, barefoot on a wet ground that's saturated with water. What better than a perfect shock is that? Do you guys see the gravity of why it's a big deal? Perfect shock. So that's the life shock, grabbing on something object. So in order to minimize you grabbing on something energized, what the code requires you guys to remove all energized things. You don't put anything energized closer than 6 feet from the inside walls of a swimming pool. So 6 feet, you can't be in the swimming pool and reach out 6 feet. So almost everything energized, lights, receptacles have to be at least 6 feet away from the inside of the swimming pool or spa or the hot tub. By doing it this way, then they minimize the chances that you're going to be grabbing on something energized. Remove it, move them away. Don't put the receptacle a foot away from the swimming pool, right? So that's number one. Number two, the gradient, voltage gradients. Voltage gradients, guys, Here's the shock. The shock is, see that little thing here, you plug it in, get it in close proximity, touch it, you get the shock. Now you are perfect. Look at that. This is 0 volt. This is 120 volt. Perfect. You can't think of a better shock. That's if that was a bulb. If that was a bulb, we'll get you a 100-watt bulb. Will get you 100-watt. Burns really good. You know, so perfect shock. Current goes right through here, back into the source, and in the process, takes you with him to join the Lord. That's the shock. Now, what's the gradient? Voltage gradients, guys. I don't know if you're familiar with this concept. If you are to drop something energized in a swimming pool, or a spa, or a hot tub, you know what happened? Because the water, the electricity will go through the water. If you would drop like a radio, stereo, or something, electricity will go through the water and create different voltage level. Look at this. So this is sitting different voltage levels. That's called the gradients, all the way to 0 level. The further away from the point where you drop the water, the further away you go from the water, the point you drop the water, the more the voltage goes to 0 level. Okay, so look at this. So now here's Chad. His foot is sitting at 90 volt, and his hand is sitting at 60 volt. So now in between, there's what, 30 volt across, right? Can you see across? So what happened is the voltage goes through the water. Then there will be different voltage levels inside the water. Inside the water. So you could have hand 1 sitting at 90 volt and hand 2 sitting at 0 volt. Now here's 90 volt right across your heart. They call it the gradient. The gradients, voltage gradients. Because the water goes, as electricity goes through the water, created different voltage levels. If you are to sit between 2 levels, you're dead. So you're not touching anything. Somebody dropped, while you're swimming, somebody dropped a heater right into the water. That could kill you. Does that make sense? That's what a lot of people don't understand, that gradient voltage. Something similar, guys, happen in a higher voltage, like in substation. If you ever walk into inside the substation and there's a ground fault in a substation, and the substation not grounded properly, you could be died just by walking in the substation because of voltage gradients. The same thing. Anyway, because of this, we typically remove these no further than 6 feet away, so it doesn't have the possibility that, you know, most of these equipment have 6-foot cords. So if you have 6 feet away, there's the possibility of dropping it while energized is slim. Okay, so protection from direct shock as well as from the voltage gradients. Any question, guys, about voltage gradients? Because it's a new concept. Voltage gradients. Okay. The NEC code book, guys, have a whole article, 680, talks about electrical wiring in a swimming pool and Hydomassage bathtub and wading and all these places where you can have people in water, you know. So have all these hot tubs and so forth. Potential contact with electricity. So you can imagine the importance of a GFCI there. You can imagine the importance of a GFCI. Right? So for example, if this is a GFCI circuit breaker, GFCI, the minute that you drop that water heater in the water, guess what's going to happen to the GFCI? Trips. You can imagine the importance of a GFCI. So number 1, guys, they move the electrical equipment away from the swimming pool. That's protection number 1. Number 2, after they move them 6 feet, they put them on what? GFCI. They put them in GFCI. So GFCI protection is very, very important in these locations. Then what they do, guys, is that they bond everything. They bond everything. They call it bonding the grid. They bond everything around the swimming pool. So the pipe, the platform that you sit to jump on, the ladder that you do to go down into the swimming pool, all these are bonded with number 8 conductor number 8 copper. And that's bonding. I'll show you the deal that you do it. By bonding it, guys, they minimize the likelihood that the ladder of the swimming pool will be energized with 120, and the swimming pool platform that you sit on is sitting at 0, and you are grabbing both of them, and you have a perfect shock. So everything is bonded together. Here's an example of how they remove objects like heaters, for example. The code require you, I have a radiant heater in this area, and I have a unit heater in the other area. So they require you, look at that, minimum. Do not get them closer than 5 feet. That's code from the edge of the water. From the edge of the water. must be at least 12 foot high. So they put it, this particular one, 12 foot high, must be suitably guarded, secured, must be permanently wired. It's not plugged in. So if you have a radiant heater, they have regulations how to put your radiant heater. Don't put it closer than 5 feet. Elevate it, because people are still running around here, right? Don't they, when they're swimming pool, they're running barefoot in this area. So if you put this one at 7 foot, people can stand there and catch it and could get a shock. So look at that. They elevate it. They move it away from a swimming pool. Same thing for the unit heater. For a unit heater, you can put, if you have a unit heater, must be mounted. You have to move it away 5 feet. 5 feet away from it. Must be rigidly mounted. Shall be moved, set back 5 feet. Must be of the totally enclosed or guarded type. This part of unit doesn't have to be elevated, but you have to move it 5 feet away. So different type of heating elements have trigger different type of application. If you have a radiant heat, it's more shock, so we need to elevate it further away from a swimming pool. So when you're designing your swimming pool, you're going to take these into consideration as you put your electrical heat, if they're electrical. If they're gas heat, who cares? Electrical heat around that swimming pool. Any comments, guys? Any questions? Comments, questions? So that's so then that's basically a few requirements. The second thing is what they do is when you do lights, here's a light that you put inside the swimming pool. You see the swimming pool light. This happened to be a wet niche light. Look what they do. They bring an equipment grounded conductor. See that green? There's a lot of conductor number 12 at least that goes all the way from the panel, bonding them. I don't know if you guys can see the green all the way. Bonding all these equipment with the conductors that ground all these objects. We have an isolation transformer that they use for some of these systems. So when it comes to wiring a lot of the electrical equipment, tons of number 8 conductors going, bonding everything else. A lot of equipment around conductor, more than normal, to make sure that a system is properly grounded. So that's a good example of what we do more when it comes to the swimming pool. So, and we'll look at these in a second. Here's a bonding. What they do for the swimming pool, guys, is here's my swimming pool, and what they do with that one is they go and bond the swimming pool. The belly of the swimming pool will be all made out of rebar and all bonded together. So all these are bonded together. These red bars is bonded, and then you go and you bond. This is what they're showing here. Can you guys see that red bars? These are in the belly of the swimming pool. They make it out of red bar. All of them are bonded through red bars here, right? Ties like this, right? And then they go tie everything to it. Can you guys see that with this conductor, number 8, copper? Everything around the swimming pool, from the drain into the diving board, into the ladder, into the fins. Everything around that swimming pool will be bonded with number 8 to the grid that made that concrete swimming pool, rebars that made the concrete swimming pool. The frame of the motors, can you see the frame of that motor is also bonded to it. Heaters are bonded, all of them are bonded with number 8. By doing it this way, guys, you minimize the possibility of people standing on one location and standing on 0 voltage and touching another location that's higher voltage.
You don't have to do like a grounding rod or anything like that?
No, not grounding rods. You still depend on the grounding rod of the building to ground the system. Grounding rods are there to ground the system.
So this would be tied into the...
Yes. Yes, absolutely. This all will be bonded together, and the equipment grounding conductor that comes with the system, you have, like when you power this, you have an equipment grounding conductor that will be tied to it. Same thing. All these equipment will be powered. The equipment grounding conductor will be tied to it. Any comments, guys? Any questions? This is the detail that you guys are going to be picking and putting it in your plan for the swimming pool. Typical detail is not really. You use copper, number 8 copper to tie all these, minimum number 8 copper to tie these. And must be solid too. It's not stranded. Solid number 8 copper. It can be covered, insulated, or bare. It doesn't have to be It could be insulated or bare to tie all these systems together. Any comments, guys? Any questions? Everybody understand? Look at that. The water inlet and the water outlets are tied together too. So everything is bonded together. So if you're standing in the water inlet or outlet and something is energized, everything is sitting at the same potential. Any comments about this bonding detail? This is the detail that you guys are going to grab and put in your CAD file for me to show for our swimming pool. Okay, so that's my grounding detail. So you guys heard about trapped underwater and the drain. This is because of the trapping underwater and the drain. I think in Minnesota, a young lady died. Got sucked into that trap, the drain. Because of all of this, the code requires you guys to have something here required labeled emergency shut-off. You have to have an emergency shut-off switch to control recirculating system for the spas and the hot tubs. So you have a push button, red mushroom push button. If you push it, if you see somebody being sucked, a kid being sucked through the circulating pump, I mean, these are a lot of power. Some of these pumps have a lot of power. So you go throw that mushroom head button, you shut it, and it shuts the circulation system and saves somebody's their organs being taken away from their bellies. So that's our requirement. In Minnesota, we lost a little kid. Do you guys remember that? When that little kid got lost? So that's supposed to, you see something like this, what are you going to do? How are you going to stop the water circulation? So you go and push that button, shut it down. Installed not less than 5 feet away, adjacent to and within sight of the spa of the hot tub. Within sight of the spa of the hot tub. And they use it, I believe, for the swimming pool too. So that will be, you see it, you see something, push that button and de-energize the system. Or it's not just being sucked, electrocution, somebody's being electrocuted for whatever malfunction there. You can shut the system down. Okay, this is just a couple of rules and regulations, UL standards, guys, for a swimming pool. Underwater lighting system have its own regulations, guys. They have either low voltage, a lot of these underwater, these swimming pool and spas light, they typically call them, guys, low voltage contact limits. They run them at 30 volt or less. They are ungrounded systems, so they're safe, basically. A lot of regulation for ground fault protection required for all the receptacles. 15, 20, and 30 amp within 20 feet of a swimming pool. You have to put them in GFCI. Swimming pool pumps, filters, and so forth. The pumps themselves, if they're single phase, 120 through 240, guys, have to be GFCI'd. They have to be GFCI'd too. Junction boxes for underwater pool luminaires. There's regulations for the type of junction box that you tap into to go to your luminaire. So these are a couple of electrical spas and hot tubs and Hydomassage bath tubs. UL regulations that regulate how do you do. How are they listed, these equipments? Okay, what I'm going to go, guys, disregard. I want to go quick here into. Okay, so we went over the electrical shock, right? Electrical shock. Here's what the gradient. We talked about, guys, the different type of heaters and the regulations. These pictures will give you regulation for them. We talked about the grounding and pulling an equipment grounding conductor. Number 12, you can see I'm feeding a transformer here. And from the transformer, typically low voltage transformer, guys, isolating transformer, you bring it here to a junction box and you feed your low voltage contact light, low voltage wet niche light. So these are another regulations. Equipment grounding conductor required. Here's the wiring method that they use, guys, for pool associated motor, equipment grounding conductor with them, and you can use either rigid, IMC, PVC, MC. Don't forget the equipment grounding conductor for all these. So that's here's the grounding and bonding. You can, like I said, with number 8, you can bond them all with number 8. Everything from the water inlet to the outlets into anything into fences around the swimming pool. Look at this, unless separated by a permanent barrier,
any and all metal shield, metal blah blah, 5 feet of the inside wall of the pool within 12 feet above maximum water level platinum shall be bonded. If they're within the 5 and 12 shall be bonded. Same thing for the fences. I believe if they are within 5 feet horizontal, anything within 5 feet horizontal, 12 feet vertical, anything metallic around the swimming pool must be bonded, including fences and so forth. So that's my hot tub and spa. Let me close that one and go back into. Okay, here's you guys the ones who have the book, all of you almost have the book now. This is the sheet that I would like you guys to go to. This has all the rules and regulation for the swimming pool, all in one. So I'm going to start right here. If you look at the top of the swimming pool, look at this. This code requirement for a swimming pool, all in one sheet. You guys have that sheet, right? It should be one of the sheets that came with the book that you have. So I know there's a lot of them. So if you're good.
I don't know where my plans are.
Did you?
No, yeah. Can we get that one saved just so I can print it off like a little?
Absolutely. I put this one on the network. It's a PDF file. Okay. No niche luminaires. There's different type. There's something called the no niche luminaire. There's no niche in the guts of the swimming pool. You can see it's like surface mount. And there's wet niche luminaire and dry niche luminaire. They have a niche and they put the light and it's either wet, the light can be wet, or dry. If it's dry, you maintain it from here. If it's wet, you maintain it from the inside. Okay, so if you have a no-niche luminaire for installation above or below water, look at this, the voltage that you can run. Can you guys see the voltage? What voltage? 15 volt. Why do you think 15 volt? Safety inside the water. Must be GFCI protected. Must have a factory installed permanently attached cord with not at least 12 foot long. Why do you think you need a 12 foot long with it? You need to be able to take it out and maintain it, right? So there's a whole lot of regulation, guys. Be listed for the purpose. Must have an ungrounded secondary. So it has to be fit from a transformer. Can you guys see that? And the transformer, isolation transformer, ungrounded, have an ungrounded secondary, have a grounded barrier between the primary and the secondary. So what they do, they have a barrier, they have a transformer that take the 120 or 277, 120 into a 24 volt, ungrounded, and they bring them to the light inside the swimming pool. By being 24 volt, it's safe for shock hazard, and by being ungrounded, guys, it doesn't shock you. It's not reference to the ground. So they're very smart the way they do it. They are inside the wall, inside the water. These are luminaires. Okay, so these are for this type of luminaire. Now let's go to this type of luminaire. Can you guys see that right here inside the water? This one is we have a luminaire. Let's go to that one. Let's go to the fixture itself. Equipment grounding. Look at this. You need an equipment grounding conductor number 12 at least that comes to the fixture. Grounding terminal, one for each conduit entry. So as you put the entry, you ground the conduit as well. This is what we call a dry niche luminaire. Has a fixed lenses, so it's dry over here. Dry, the water cannot get in to seal the water. I think there's a wet niche luminaire. Here you go. Here's a wet niche luminaire. Wet niche luminaire, the water can get in. That's okay. It's rated to have the water in it. Access by removing lenses from the pool. So you remove it here and change it. But look at all of them are coming from where? Can you guys see that? What is this? Transformer. Take the voltage, the high voltage to a lower voltage, isolate it, feed it from a GFCI. Well, if they're low voltage, you don't have to have a GFCI. And so for safety, can you guys see that, how they do that? They put them inside the water. They put a transformer. They put a transformer. Okay, so that's, and with an equipment ground conductor. I want to bring to your attention, guys, here you require a receptacle. The NEC code book require a receptacle not closer than 6 feet, not further than 20 feet away, GFCI receptacle, at least one receptacle. You have to have at least one receptacle. Not closer than 6 feet, not further than 20 feet, GFCI. Any receptacle within 15 and 20 within 20 feet must be also GFCI. So you need only one receptacle. But if you decided to put 25 receptacles, all of them are within 20 feet of the swimming pool, what do you need to put them on? GFCI. So, but how many do you need? One. Okay, so that's the receptacle. Look at this one. There's certain receptacle, guys, can enter that area. I don't know if you know the 5-foot area here. For example, a receptacle that provide power for a water pump. If you have a water pump and there is a receptacle that provide a power for a water pump for other directly related to the circulation system shall be located at least 6 feet. 6 feet, at least 6 feet from here, at least 6 feet from the inside of the pool. The receptacle shall be single of the locking and grounding and shall be GFCI. So if you plug in the circulating pump, it has to be not closer than 6 feet, GFCI locking type. So that's just for your pump. Any comment, guys? Any questions? See the rules? Look at the light here. I have a light. Your light here, you have to clear, I don't know if you guys can see the distance here. You have 5 feet. You move your lights all 5 feet away. If you put it in this area here, look at the requirement. The requirement here, 5 feet away, GFCI protected, or higher in this shaded area need not have GFCI protection if rigidly attached to the structure adjacent to blah blah shall have a GFCI protected if installed less than 5 feet above the maximum water. If you install it lower than 5 feet, you have to GFCI it. So I'm hoping there's a lot of rules, guys, in terms of where to put the light and you GFCI them and so forth. Look at this one. Existing luminaires are allowed to be within 5 feet from the inside of the pole. So located less than 5 feet above the water. They have to be also 5 feet above the water. But look at that requirement. What do you see? GFCI for only for existing. So typically, guys, luminaires, you have to shift them away 5 feet away from the from a swimming pool and as high as 5 feet or triggers a GFCI protection. Right above the water. Look at the luminaire right above the water. The rules for luminaire right above the water, unless the luminaire are listed, they have to be what? 12 feet above the water. Unless they're listed. When you put them right above the water, you have to put them 12 feet above the water unless they're listed. If they're listed, then you can put them as low as 7, not lower than 7.5 feet, but that will trigger you to put what? GFCI protection. They're listed, then you put them 7.5 feet, but you have to put GFCI protection for them. So the rule is what? 12. Lower to 7.5 if they're listed, and what do? You GFCI them. So that's the rule for that one. Power lines, look at that. Power lines right above the swimming pool. Here's the rules for the power lines. Insulated supply service drop from this voltage to this voltage, blah, blah, blah. Look at that. At least 22.5 feet clearances in any direction to the water edge, blah, 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 platform, everything else. You have 22. If you were to bring the power over your swimming pool, if your neighbor decided to dig a swimming pool right under the power lines, make sure they're clearing it with 22. Remember, the code requires only 10 for the power lines. Now you're getting 22. Communication lines. If you have communication line, what's the number? 10. You have to clear by 10. So these are rules for the power lines. Okay, moving on. We got that one. Okay, here's the pump. If you have electrically operated pool water motors, controllers, and associated guys shall be at least 5 feet away from the inside of the pool. The motor and the controller shall be GFCI protected. 5 feet, GFCI protected. So you put them 5 feet and you put them in a GFCI protected. Maintenance disconnect switches for swimming pool, hot tubs, and so forth. You have to have a maintenance switch for readily accessible within sight and be located at least 5 feet horizontal from the inside wall of the pool and the hot tub for disconnecting the equipment. This, like for example, the cover and so forth. This is for the cover. The motor, if you have a cover for a swimming pool, you have to disconnect the controller within sight, at least 5 feet horizontal from the inside wall of the spa and the hot tub. Transformer enclosures. This is for the GFCI for your transformer. Let me go. Okay, switches. Okay, switches. Switches must be located at least 5 feet from the inside of the swimming pool, unless separated by a solid fence wall. Some low voltage switches are listed for within the 5 feet, but typically 5 feet is the magic number. Okay, so what else I'm going to pick? I'm picking certain things, guys, because I believe they're important. GFCI protection required whether the motor is connected. Okay, here's a good one. If your pump is running at 120 all the way through 240, 15 and 20 amp, they require you to have GFCI, exactly like the pumps that you guys have with us. They're going to be wiring. They're running at 240, the pump for a swimming pool. You're required to put GFCI on it. How do you put a GFCI on a 220? Circuit breaker. So the circuit breaker that you feed to the pump has to be GFCI. Okay, so there's certain things. I think that's probably most of what we do. Okay, any comments, guys? Any questions? Comments, questions? There's a few things about the junction boxes, transformer, and GFCI enclosure must be at least 4 feet from the inside of the wall when you put the enclosure 4 feet. So there's a few, if you were to, okay, so if you were to wire a swimming pool, probably this detail, guys, would be a perfect detail for you. Now, reflecting, since we're passing through this, reflecting on what we're doing right now for the project that you guys are doing, a quick reminder, you need one receptacle not closer than 6 feet, GFCI. You need to have the pump need to be also on a GFCI, circuit breaker 2-pole. You have a heater that you're going to be wiring. That heater will be located around the swimming pool. We're going to have light. Your light are going to be further than 5 feet away from a swimming pool. And we're going to have a switch for the swimming pool light. Any comments, guys? Any questions about the swimming pool? The detail of the ground and bonding, you already have the detail. You don't have to draw the detail for me. So you have the detail. The rest of it, guys, is FYI. So I don't know if we forgot anything. Transformer 120. Look at the transformer they use for wet niche, guys. 120 volt primary, 15 volt secondary, 1 kVA isolation transformer. When they feed, if you want to use these lights, for your project, you wet luminaire fixtures, then be aware that this will have a transformer that's going to be taking the 120 into typically 15 volt or 30 volt or 24 volt. And dumping it across isolation transformer ungrounded system for safety features. So every time you see that wet ditch luminaire, remember they're running him typically at a lower voltage, non-lethal isolating transformer. Okay. All right, grounding. That's all what I have, guys, for you in terms of the swimming pool. Any comments, any questions? Please feel free to review these. Like I said, for our project, don't forget that GFCI receptacle not closer than 6 feet that you need. Your pump is going to be in GFCI circuit breaker, and your heater is going to be under we have a patio, so it's going to be under the patio, not above it, so it doesn't have to be affected. Switch is not closer than 5 feet. When you put your switch around the swimming pool, make sure it's not closer than 5 feet. Otherwise, you have to have a listed switch, listed low voltage switch. Any comments, guys? Any questions? Comments, questions? So that's basically for your swimming pool. Let me just go very quick, guys. For swimming pool. I don't know if we forgot any. Okay, now. Just a little bit, we're not doing storable pools, guys. If you have a storable pool, almost the same rules. If you have to have a GFCI, you have to have one GFCI, not closer than 6 feet, not further for a storable pool, not further than 20 feet, GFCI'd. Any receptacle within 20 feet radius of a storable pool or a permanent pool have to be GFCI'd. The pump for a storable pool or a permanent pool that runs at between 120 to 240, 15 and 20 amp have to be GFCI. Same rule for both of them. Okay, so for storable for spas and hot tubs, guys, spas and hot tubs, at least you have to have at least one receptacle. Exactly like same rule for the swimming pool. Not closer than 6 feet, and it has to be GFCI, one receptacle, 120, 15, or 20 amp. Receptacle must be located at least 6 feet from the hot tub. 120 receptacle, 30 amp or less located. Anything located, guys, within 10 feet of the spa with a hot tub up to 30 amps have to be GFCI'd. Luminaires within 5 feet above spa or hot tub, so ceiling, blah blah spa panel above spa or hot tub, and 5 feet from the inside wall of the spa. So you have to move 5 feet away from the inside. Then if they are to be not less than 12 feet above, if not GFCI, almost the same rules, guys. Either you put them 12 feet above the spa when you put your light, or you lower them to 7.5 and GFCI them. How do you GFCI a light? You put a circuit breaker, GFCI circuit breaker, not a GFCI receptacle. So to be 7.5, if less than 7.5, must be GFCI and be suitable for dam location. To be not less than 7.5 if GFCI protected. If less than 7.5 must be GFCI. You actually can go to lower for the spa. You can go lower than 7.5, but it has to be listed for what location and still GFCI. From the top of the water. From the highest top of the water.
What about the equipment that's running the pool? That's GFCI also?
Yes. If they are 15, 20, 30 amp, 120 or 240 system or 28. If they're 3-phase, in our project they're all single phase, so they have to be. Switches, the same for spas and hot tubs, guys. You cannot put a switch closer than 5 feet from the inside wall of a swimming pool, exactly like the spa, the swimming pool. Bonding, you are to bond everything metallic with number 8. Anything within 5 feet of the spa or a hot tub must be bonded with number 8 conductor cover, solid. Hydromassage bathtub, same thing as GFCI protected. 120 single phase are located within 6 feet. Measure horizontal from the inside wall of the hydromassage bath must be GFCI. Anything within 6 feet of a hydromassage bathtub have to be GFCI receptacles. But I believe you cannot put them within 6 feet of that. Okay, so same thing, bonding with number 8. You have to bond the plumbing piping system to the frame of the pump, the hydromassage bathtub, with number 8 copper solid. Number 8 copper solid. Okay, so all 120 single phase receptacles that are located within 6 feet, measured horizontally from the inside wall of the hydromassage bathtub, must be GFCI. Okay, I guess you can put it for hydromassage bathtub. You can put them within 6 feet, but they have to GFCI. Unlike a swimming pool, where we can't. Okay, so that's the rules, guys. A few rules about hydromassage bathtubs and swimming pools and storable pools. Any comments? Any questions? Comments? Questions? Summarize. For swimming pools, receptacles shall not be closer than 6 feet. They have to be GFCI between 6 and 20. Lights, typically 12 feet. You lower them to 7.5. You GFCI them. They have to be listed for what location. Lights, typically low voltage contact limit, they call them. Isolating transformer, feed them. Wet niche or dry niche. With an equipment ground conductor number 12. Everything in the swimming pool have to be bonded. Everything metallic within 5 feet from the swimming pool to a height of 12 feet have to be GFCI, have to be bonded with number 8 copper solid. What else? The pumps themselves, if they are between 120 to 240 single phase, 15 and 20 amp, they have to be GFCI. And there's a few rules about the heaters and so forth. Is this enough, guys, to get you up and running for the swimming pool, designing our swimming pool stuff? For our system, I want you guys to show one receptacle, at least one receptacle, with the rules for the receptacle, one switch, a couple of lights, wet or dry niche luminaires, and you also need to show a heater because we have a water heater and a pump, Any comments? Any questions? Karen? Does that make sense? Yes, no? I can't emphasize this sheet, Derek, if you are involved in a project that has swimming pool. Let's summarize a lot of rules. One sheet, really nice. I always bring to the attention is the power lines. When you decide, if you decided to put the swimming pool and you back ride at them,
The first thing you need to know, make sure you're not right underneath the power lines. Otherwise, you might have to go to the mast or raise the mast to clear the 22 feet, 22 and a half feet.
Can you put that one
Oh, on the PD, yep, on the network. Absolutely. Okay, that's all I have. Thank you, guys. Let me